We're going to start in 1 minute.
I'm just gonna leave that on. I'm gonna leave mine on just to make sure it doesn't mess up any Zoom stream. Oh, yeah. There's someone sitting in front of it. I'll grab you one from the cooler, which is almost. Almost. Very similar.
Thanks, Tim.
Couldn't be easy.
Okay. Hopefully, internets are listening, and hopefully you can check the YouTube stream. So my presentation would be not that exciting because there's no AI thing, but I think it's important in terms of getting data. That is also important. So since we're talking about pizza, and we need to mention pizza 3 times, right? So the first time the pizza was mentioned here. How much pizza we sold? That's the restaurant, the question that the restaurant owner would be very much interested in. Or if you're running chain, you don't really care about like a particular slice of pizza. You care how much revenue you're bringing into the table, or like a particular branch is getting the selling pizza, and how many orders we're selling, and how busy is a restaurant. So those type of questions you need to get answer relatively in the real time, ideally, or like you're looking for the where to order your dinner. Maybe you travel and you're not in the mood to go in the restaurant. You want to order something from Uber Eats, for example, and you check in what's the average delivery time from the restaurant in the area in the last 30 minutes. So it sounds more or less real-time-ish. So in this presentation, I would like to show you some of the tools that you as an application developer can use to develop systems that will try to answer these type of questions. Okay. So that's kind of like a premise. And yeah, there will be dashboards and there will be some advices in terms of how to build those dashboards. But dashboard is like insights we can get straight. So pizza number 2, it's the generated image about the pizza meetup and the real-time insights, and there's some how the Midjourney analytical stuff. So I say, okay, give me an image of pizza, slice of pizza in the real-time analytic world. I'm going to be talking about the lab database, analytical database called Apache Pinot. It's an open source project that was, as many the modern open source project was developed in LinkedIn. How many of you know other open source projects that develop in LinkedIn? Maybe starts with K. Kafka. Okay. Yeah. Anything else? Any? One? some of the things around managing Kafka cruise control also. And Apache Pinot also was developed in LinkedIn. There's some projects that like Espresso and Voldemort, they were developed. They kind of sort of, the people were talking about those that were not that popular, and they were not, I believe they are not open source. I'll show you, because I build highly scalable and highly available Hello World applications. Most of the time they over-engineered, but what's the fun if you're not over-engineering your demo? So in this particular case, in this particular example, I'll show you full-blown stack of technology can be used to build real-time analytical applications. So, and some people who've been in the data world for a while, they might say, okay, so is it like a kind of contradicting thing, like real-time in analytics? Usually analytics is something that, we can good enough next day. We have a day of business is closed. Overnight, we do have some ETL job that extracts the data from our operational data source. We'll be doing some of the crunching, the cubings and stuff. And after that, we will print out the report and deliver this report. Stakeholders or shareholders or the people who will be responsible for dealing with the making some critical business decisions. Now, and this is where it brings me to explaining where we're standing today in 2024 in terms of landscape of the analytical applications and analytical workload. So I would like to start with bringing the little bit like a scientific, or like a not scientific, but at least approach that visually will show you where different users stand in terms of one against each other. So in the y-axis we have the batch and the real time, and the x-axis we have internal and external. So with the internal external is something that you run inside your organization. You're running this to support business, and you're not necessarily world application. It's not your core business. It's something that supports your business. And the batch in the real time, it's a fairly fairly self-explanatory in terms of how fast and how quickly you're getting this data. This data will be used for certain decisions that you make inside your business. So we'll start with internal and batching. Typical example, reports. What's cool? The Crystal reports. How many of you use Crystal report? Cool. A few people, a few veterans here. No, not now, because I'm trying to remember what was the cool thing at the time. So what was another one? The BERT, it was a part of the Eclipse, also like a reporting system. So different dashboards that they build internal, and those dashboards is not that fancy that we have these days. Those dashboards might be, just show some data that is not changing that often. You might have a dashboard that will be in your office, and it will change, I don't know, every morning. There's some internal things that's also important for a business, like observing how many requests you're serving, or how many users you serve, or how many orders you fulfilled, and things like that, or observe some of the technical details. What's current load average in the system, how many users hitting the system. So something that is important to React, because you might have SREs on call, and they will be making sure that the CPU load average is not be more than something. So this is something that is a real-time-ish, but also internal, because you're using this to support business, but it's not your core business. Now, user-facing analytics. I'm gonna table this for now, because I will be showing the examples of this particular functionality. But in general, this is something that your core business is kind of like either selling this in form of UI or functionality of your application, or maybe API that you're exposing for your customers. And those need to be kind of like a real-time-ish, meaning that reaction time should be less than hours, minutes, seconds, ideally. And some of the reporting features that your system can generate overnight, and you can send to your customers or whatnot. So in terms of like landscape of software products that can support this. So data warehouses, this is something that's I'm not a data guy. I become the data guy, but before that I was application developer. And in application development world, like a data warehouses is maybe synonym of the monoliths. And when we're talking about our monoliths, we're usually not bragging about this because we feel a little bit guilty because of this. And some people don't like to talk about data warehouses, but it's still there. Like some of the systems that require have a lot of data in this legacy data warehouse systems. Hadoop was one of the systems that was used to generate these analytical results that was batched and to run some internal workloads. Snowflakes. Some of the systems, more modern systems like a Trino that allows to do kind of federated of queries across multiple different data sources, BigQuery and the Snowflake, there's modern data warehouse systems that for the modern world. But again, you're not using this data to build the applications, to expose this data to outside world. So for internal and the real-time data, any type of the time series database, Datadog, Grafana, the Prometheus, whatever. Usually for exposing this information, analytical data as a feature of your application, you have some sort of either a prepare this data and cache somewhere, so it will not require real time. So it still will be crunching those numbers overnight, and after that it will be cached in the form of either some key value store that will be exposed to application, or something that you can publish this like in files and PDFs and things like that. So in the last couple of years, we've seen a rise of new cool things. Things around Druid, ClickHouse, Rockset, those systems allows to build data-driven features in your application using analytical approach. And obviously Pinot also is there, and we're going to talk about the real-time analytical systems and how they different and what's the fuss about this. Oh, we have interruption in the word from our sponsor. So we at the StarTree, I work at StarTree, and we are making the community conference called Real-Time Analytics Summit. And it's going to happen in almost in 2 months, or no, less than 2 months. It's going to happen in May in San Jose, California. I will be doing a full day training on Pinot, hands-on training, Pinot, Flink, and Kafka. I also will have my friend from Confluent, so we will be doing this together, things with Kafka in the Pinot. And also there will be very cool speakers. And if you're interested in this type of jazz, real-time analytics, user-facing analytics, check out this. Since we are friends here, thanks for Tim for inviting me. 35% off on me. If you wanna join. Now, so in terms of like I already mentioned this in the title of this presentation, industry leaders using real-time analytics. But let's talk about why. I mentioned this the LinkedIn thingy, and a couple years back, the only use of LinkedIn was there on data resume. There's not much else there. It was cool that there's like URL and you can put the different certifications, you can put your job experience, but at the end of the day, it was still kind of glorified the resume. And the people on LinkedIn also think about this, like, okay, so how we can use this, how we make our platform more engaging when the people will be actually, and discuss about certain. So they come up with this idea that's called Who Viewed My. Have you using this type of feature? It's cool, isn't it? Because it's kind of like interesting, like why people look in my profile, what kind of people look in my profile, and like what it's sometimes also filtering when you see when you saw your profile, thinking, wow, that's cool, I'm kind of popular. Now, to build this system, first attempt was to use the search technology. Many of you heard about this. It's called Elasticsearch. Failed miserably because it was not designed to be. It's a great search system. You still can use this for writing the full text search type of capabilities, but it were not designed to solve this particular problem. Specifically, every time when someone clicks on your profile, it's actually, there would be event placed inside the Kafka topic. And before that, it was collected in Elasticsearch. And from the Elasticsearch, they need to run this aggregate to get idea like who was there. Plus, if you start adding different dimensions in terms of geography, where they come from, level of seniority, you want to see if your CEO or CTO look your profile versus people in the same tier, for example, in the same level of seniority. You want to see dates, so it's another dimension. Those problems can be solved, right? Can be solved with the existing systems because analytical systems, they're designed to be serving multi-dimensional queries. However, it's not very interesting if you will like, okay, who saw my profile a week ago? It's not interesting because you want to know who saw your profile today, couple hours ago. For example, you went to interview, you're expecting that them to call you, and all of a sudden you see, okay, a few people from the company that you just went to interview start looking to your profile, meaning that, okay, I scored this. And this creates engagement. That's create the people the desire to stay on this website. So you don't care about who viewed your profile a year ago. Now you need to have this information now, like updated in real time. So for this, solving this particular problem, they had to come up with new type of the system. And it was obviously Apache Pinot, and we'll talk about this. Before I'll show you a few other examples. Some of the information on newsfeed. Newsfeed was the next thing that was covered by same data. Or network post update, or some people on your network post the news. Now, you want to have your newsfeed updated in real time because you want to know what's going on there. So this is kind of like the SQL query that will be representing what is happening with your network. So, and they start building more and more pieces of functionality based on same data because data is already there. Kafka captured all these events. Now you need to ingest this into database. Build the queries. That, first of all, a high current. You have thousands of people hitting the LinkedIn website, and you want to have many people seeing your profile. You want to have this data fresh. You want to have data the minutes or seconds. And also, it's going to be like very, the many queries is going to happen. Another example that it would be very much to my attempt to create this functionality. Also uses Pinot, and they also build something for restaurant manager. So it is like a different help different restaurants to be customers, and it's their core business because they have a data about the who can deliver. They can get information from the restaurant in terms of like load of this restaurant, how many orders they're serving, and they want to give the ability of seeing this inside insights for people who use their platform. So they want to have customers to use their system. And this is what we're going to be building in this particular case. So let's break. We have capturing orders that happens in our system. Users go in our website, order. We have a, let's say, operational data. We have our inventory. In this particular case, our products, different pizzas. So we have ability to enrich the streaming data from that comes from the orders with data that we have in our products. So in this case, we're going to joining this stream to table, and we will have some like product that will include all possible information, and we want to have to query this data in real time. So when the order comes in, we want to have this data updated. And we're going to be using Apache Pinot for this. And I mentioned that development myself, still like to tinkering with the code, frameworks. I hate SQL, but I'm here. So thing is, you're not exposing the SQL is still. But for me as application developer, that will be powered of this data, but still will have all this like features like a nice UI, nice cool graphs. So these queries needs to go somewhere where I can be, use this to visualize. And in this particular framework or template, anyone before? Like I just plug the Pinot driver, put the SQL and the functionality. Integration also exists. Cool frameworks like a superset. You can like pretty much any system that can talk to SQL. They can talk to JDBC or Python. We have a Go driver, Java, JDBC, and Python driver. So that's how I said this is going to be like a super over-engineered. But think about this. This is kind of like emulates the idea of event-driven system that captures the data. That's yeah. This part will emulate our event-driven real-time functionality, where people will clicking around, people ordering things. This will on the MySQL integrate with the operational. Think about this as a modern structure, because we're going to be using change data capture, or in this particular case, I have a service that emulates this load from database. The transform is going to happen on the Kafka Stream side of things. A join and enrichment. So like for every order, I will only have like a product ID there. And I want to kind of like a flat map or like expand this and have like enriched orders that will be landing in Pinot. So Pinot supports two types of ingestion. I still have to show you how it works. So Pinot works with workloads, real-time workload. So there's ability to do batch loads. There's jobs that allow you to just like feed the data from where like file system, or you can use integration with Kafka. It will do a real-time ingestion. Like every time when we will be pushing this event inside the Kafka topic, specifically enriched orders, the Pinot will take these segments into a real-time table, and it will be available to query immediately. More importantly, inside the Pinot, we can have the current performance out of the box is not suitable for the serving our queries. We can enable all sorts of indexes that are available in Pinot. And there's like even special type of StarTree this is where the implementation abstraction leaked from the implementation of database into the real world, hence the name of the company, StarTree. So if you ever done some sort of like an ETL where you need to pre-aggregate some data before query, or you need to do kind of like a pre-cube data, you need to have a play around with different dimensions. So think about the StarTree index as something that does this automatically based on usage. The more you use the data, the index would be smart enough to rebuild and can build different paths of execution based on different dimensions. So let me quickly show you how it actually works. If you like to play around yourself, again, it's also one Docker Compose file, includes everything. I tried to make this work with one click. There's just like a make command to run this. And this is the QR code that basically gets into this Git repository. And let's see. How does it look like? So let me see. So this is how it works. So this is how it works. And this is the Streamlit UI. All these components was developed with Streamlit. And every data element here backed by particular query that runs against the Pinot. So we have the how many orders we, let me see. If it refreshes, like refresh rate, let's do this more. Yeah, so we can see how many orders would be generated within last minute. It's always nice to see how revenue grows, obviously. We can see how many orders were placed in the the last orders and what were the most popular categories. So there's some side orders like fries, maybe vegetarian pizza, even pasta. So, and with this, we can see the most popular items, how many of them are sold, and how many, when the people ordering this, what's the average quantity of those items. So, again, as a disclaimer on the very beginning, this is not backed by the real data. I had to generate something that would be exciting to show. So that's why I do have the program that generates these orders. So, when I look into my Kafka topic, all my orders will go into this orders topic, and this is how it looks like. Inside order, I have some user who placed this order. I do have the items, and all these items just include product ID. So not super useful unless we will do some sort of enrichment of this data. And there's a different ways how you can do this enrichment. I do have a version of this application that uses the Python framework called ByteWax. I use the version of this application that uses Kafka streams. Anyone like Java people here? Okay, few people. So Kafka streams, it is the built-in framework built-in Apache Kafka. It's a Java library that not allow you, there's no like server, there's no cluster. It's not like a Spark you're running or something like Flink. It's just the code that you write. And in this particular case, my code is implemented using this framework called Quarkus, just for sake of having the things figure out with Docker, the configuration, and all those kind of things. But essentially, the Kafka streams would look something like this. There's two methods. One method will take every order. For every order, we need to create the like expanded version. So we'll take the orders. We read inside the order we have the different products, and we're creating another stream. That's what the flat map does. It gets this one stream and creates another stream that will include order ID, product ID, and many other things. Why are we doing this? Because this we're going to use this as enriched stream. So we will take the product information and join with this stream of data that was like exposed. And the way how it looks like, so remember this is our order, order placed, bunch of items here. And if I go to my topic as a result called enriched items, each individual item will include information about the product and about particular order. So basically, I'm trying to turn my data into one big table that can be easily queried. Like I'm turning the data that comes into my system through operational data store and through the stream. I turn it into the format that would be easy for you to do like any type of analytical stuff. And for this, I do have a connector that listens this Kafka topic enriched items, and the Pinot will suck this data inside the Pinot table. So in this particular case, order items enriched is going to be my orders. So I do have like order quantity, product category, product ID, product image. So as is, but it's in a flat form. So now I can run some sort of queries. And one of the things that's, again, this is information in case I screw up, I have some commands that allows me to, for example, to run this, copy paste. And if I go to my query console, so this is particular, so what it does, so this query will take the most ordered product categories for the last 5 minutes. There's the special type of workflows. So when I run this, so it takes me 5 milliseconds to run over. Let me show you once again. So if we have inside the Kafka topic, how many messages we have? We have roughly 500,000 messages of orders, and those data already dumped in the Pinot. So if I run this with this, this is the result I'm getting from the data. I'll take this order and feed this into one of the dashboards. Once again, let me show you the diagram, like where we were standing. Where's my keynote? So we do have. Oh, nope. Thank you. Data through Kafka land into Kafka topic. We have products from operational data store. We have Kafka streams does the join, and we do enrichment on the Kafka streams. We dump this into Pinot, and after that, we are querying this data using Pinot and Streamlit integration. Any questions about the demo so far? Yes. Say it again? Yeah. Order, we take a collection of product items that was there, and we produce another stream that would be kind of like have a flat structure. After that, we'll take this the product ID information and replace it with the actual product data. So each and every message in the stream will have order information and product information. So when it lands inside a Pinot, we will be able to query this data and run all the sorts of like average. We can run all these counts and all these kind of things that we would be interested in doing. I have another query, for example. So with this, we can do, we can build some sort of the table result where we can get a number of events for the last minute, between 1 minute and 2 minutes, and we get the like average, we get the total, and we can run this query. I'm wondering why it says still total number of docs is not more than. Should zoom. Okay. So we're getting, this is the number of orders per minute. How many events happened within last minute, and like how many like events happened in total events. So we take the price, and we're getting the revenue part that I'm displaying on the dashboard. That's what this what the query powers this type of thing. Any other questions? Okay, so and this is also a very cool thing where we're going to talk a little bit about the distributed architecture. So when we're talking about the batch ingestion, let's say we have a file that will include number of this kind of JSON events. It can be just the JSON lines, or it can be array of the things, but essentially it's kind of some event, clickstream, something that happened on the website. And what the Pinot does when we do ingestion, we're ingesting this into table. Table contains things what called segments. Other distributed system might call it partitions. Some system call it shards. It's the unit of storage of this information. An interesting part about the segments is that data stored inside the segments in what we call a columnar structure. So instead of like your OLTP database store everything per row, like we have one record, we store it as is. Here, we turn it into columnar form. So instead of having one record that will include this information, we have segments that will include only IP addresses, for example, or only time requests. So we'll take this and kind of sort of like pivoting this. And each segment would be spread across multiple nodes, and each segment will include its own kind of like a piece of data. With this format, it allows the system to run different optimizations. We can apply different, depends on the cardinality of the data. We can apply different, say, strategies to reduce the size, or maybe like figuring out how we can store only one particular thing, so compression and all this kind of stuff. Also, these segments we can spread across multiple servers. And servers, there's actual thing that will be storing the data. So we come up with the name of the server ourselves. No one tells us. So I think it's very inventive, right? The server serves segments. Okay, tough crowd. Okay. Yeah, so the different, now it's going to be cooler because, for example, in Kafka, they call the servers brokers. We also have brokers, but the broker does slightly different things. So broker would be responsible for taking query and will take this query apart, because broker knows where particular segments are stored. So it will send these queries to particular segments. So for example, if we need to data that will be stored in segment 2 and 8, we can run this on server 2 and server 3. And when we get the response, we get the response back, and the broker will collect this and send back to our application. We use Zookeeper here to maintain the structure and know which like server owns a particular segment. The segments can store inside the server disk, or it can be sent in a deep storage. In this particular case, it also kind of cloud ready because you can actually have this deep store somewhere like in S3, and like when you need to query this old data, your like a P99 metric will skew because you need to download this into memory again, and after that serve it from the memory. But it's already kind of like have a concept of like separating storage across the store. We took this took this idea in StarTree Cloud, and we use this concept of the tier storage to optimize how the data, how data will be stored for the longer time. Now, clients talk to brokers because we're sending the query to broker. Broker will be responsible for like scattering this request, and after gathering the results from the servers, and we're getting the data can be ingested by servers as well. So when we're creating this, there's no even though Pinot supports SQL, there's no insert type of query. We doing this, the data would be ingested through ingestion jobs. One of the jobs, for example, if we need to do the batching thing, there would be a job that will be constantly reading your, like once read this data source, and after that, data will be available. Or if it's a Kafka example, it will be constantly reading from Kafka. We only give you kind of like a select star type of select from whatever type of queries. You cannot do inserts here. With Kafka though, we support upserts. If the data with the same key will come in, we can update real-time segments. So naming is hard, and the tables that will be populated from the batch ingestion will be called offline tables. I know it's a not super intuitive name because it will sound like this table will not be available for querying, but despite on this name, it's actually available to the query almost immediately. And this is our segments. Every time when we do ingest, we turn this into the thing. With the real-time ingestion, here we were a little bit inventive with the names. It's called a real-time table. And with the real-time table, we will be listening. I don't know if I have this slide because it's a slightly, how many of you are familiar with the concept of consumers inside the Kafka? How when you read, the consumer offset would be stored inside the Kafka. Anyone? Yeah, so forget about this because we're not using this here. So we're using low-level consumer API, and we have a segment per partition inside the Kafka, and we maintain a position of this offset inside the Pinot. Technically, it will be stored inside Zookeeper, but Pinot will be responsible for maintaining. Why we need to do this? Because there would be some jobs that will be responsible for rolling over certain segments, for doing replication and all this kind of stuff. So all these jobs will be taken care of, how the data would be spread across a Pinot cluster. And all this information would be handled by Pinot. There's a concept of minion. It's a special type of jobs that will be running inside a Pinot, and there's this whole framework that will be responsible for dealing with this type of things. So let me show you quickly the configuration for these real-time tables. Every time when I need to create something, it would look something like this. I need to create a table for my orders. I need to create a configuration for the table and the schema to tell Pinot how this data would look like. And inside where's my Pinot, say orders. Here's my schema. This is how my data would look like. ID, user ID, status, and items. I store information about the orders in a JSON, and also we have a JSON index. In a Pinot, you define a JSON path, and you will be able to query inside this JSON thingy. And the tables would look something like this. The most important part here is table configuration, and this is a real-time table. So we support stream type Kafka, we support Pulsar, and we support Kinesis out of the box. And there's a framework that allows you plug virtually any type of real-time system. And this is some configuration that would be specific to this Kafka implementation. We also can do, when we're ingesting, we're not only ingesting this as is, we can do some sort of like a small transformation. So in this particular case, we also can extract the quantity for example, in this particular total quantity, we can run JSON path type of operations. We inside the quantity, we're also injecting the number. We're looking into order, and after that, we're inserting this as a field total quantity, and number of products that was ordered in this particular order. For enriched, it's another option. So we do have a schema that will include information about product name, product ID, product category, image, because it's going to be include all this information from Kafka. And again, it's also the Kafka topic, and we do have this functionality here. Does anyone have a question? I have a question. What about joins? Yes, it's a great question. So the reason it's a normal question everyone is asking about joins. You're talking about database, everyone will be asking about joins. So as you can see in this example, I use some external system to do this type of join thing. But the information is there, so I can do this on the Pinot side of things. I think before 1.0, Pinot didn't have have like a very limited support of joins, and the kind of like the concept was there, so people would use things like a Trino to perform those joins. Now we do introduced special the next version of our query engine to join supported locally, join supported out of the box. So technically, I can do the stuff without having Kafka streams now. So I can ingest my products from my MySQL using either some sort of like application that will use Writer API, or I can have, for example, my data of products ingested inside MySQL in the form of a CSV file. I can use the CSV file to ingest this directly into Pinot, and after that, I can use join. If I want to use joins and stuff inside the Pinot, there is a special check mark, says multi-stage engine, that will allow to perform join out of the box. I have if you're interested in these examples, we do have I think, let me see. I think I make this quick start. It's still private. I'm working to release it, but essentially this is examples where I have a movie information and ratings information. So movie is my offline table, and the ratings is a real-time table. And I'm doing things with join that would look something like this. So in this particular case, I do have movies, but I also do left join of movie ratings based on the movie and rating ID. And after that, I'm populating movie information and rating information using this type of query. So answer is, you can do pre-join outside, and after that, like a store result in Kafka. So I have another example working in Works that will use like a Flink to do the similar thing that Kafka Streams does. But now some of the functionality with joins already supported inside the Pinot. So thank you for this. If you're interested in this, join our Slack community. This is open source Apache Pinot. It's confusing. It's open source Slack from the Apache community. This is StarTree Slack if you interested in talking about some StarTree product. We have a cloud product. We have an anomaly detection product that allows you to monitor data streams and build some sort of logic to some of the anomalies called Third Eye. And again, some one of you at the Real-Time Analytics Summit be organizing this, but there would be people, other companies that would the board. It's pretty cool technology. They kind of like use Kafka with tiered storage and like of Kafka separated the Kafka engine, the Kafka from the storage. So it's a pretty cool event. Again, training day. I'm working really hard to put the very cool content there. My name is, as always, have a nice day. And we still available for engagement if you have any questions that you want to ask, like not in front of people. Yeah.
I went to that last year, it's really good.
Thank you. This year? We can,
Would you have to be at a different conference on Saturday?
because I thought like
Except my talk.
the talk as well.
What?
Yeah, that's why. That's how I was able to the only reason why I was able to come, I can do training like whole day, just like okay, sold out. Yeah. People from Stripe, LinkedIn. So the people who run this in yeah, and some people who run the cloud, and there will be some engineers from StarTree will be talking. So yeah, that's gonna be. We will have a cool backpacks. I saw design T-shirts, the hoodies for speakers. Exactly. Yeah. All right. Thank you. Yes. Yes. So yeah, so since we're controlling the ingestion, so we will able to, when we read particular, say we're reading this like CSV file, we figure out, okay, so this is going to be our. We store like the column names, and after that, based on the index of the element inside this row, not the hashed. So it can be hashed. Need to do some sort of like optimization for compression or whatnot. Again, depends on cardinality. Say you have a flight information. Every record will have a flight information, have a flight date, flight number, the tail number of the plane, duration, and all this kind of. So you will be able to, for example, like flight number would be having some of the, it would be something that very difficult to compress because they are pretty unique. But things around timestamps, things around durations, those things will have a like higher cardinality. So you will be able to do some sort of optimization, create the dictionary that will include like some of the things, and after that just only store dictionary ID instead of actual record. And we pivoted during ingestion. So that's what you are more concerned with the you concerned with the row-based locking thing, any of this. If we need to do update, it usually comes through the upsert. How, I don't know, like log-based trees will be doing compaction. The all data still. There's a bunch of different techniques that's used during ingestion. So we control ingestion, the job that controls ingestion, and that how these segments are formed. So that's why we will be able to, turn around the data. So the query running this, the analytical queries would be much easier and faster on particular column. You don't really care in this query of particular row. You only care about sums, averages, some filtering, and all this kind of stuff. And it would be much easier and more efficient to execute this when it's data stored in columnar form. So you don't need to do any like a post processing with the data. So that's why OLTP system is not very good. You still can do analytical queries on your OLTP system, but you need to mess around with the indexes and all this kind of stuff. So you need to do something with this data, or you run pre-aggregations or something like that, some background process. In this case, you need to maintain this, how often this pre-aggregation would be running, so far and so on. So I don't know, it was more than 30 seconds, I apologize. Which Delta format? Oh, like data lake. So we might support this in the cloud. We might not support this in open source. So yes, but only cloud. You need to check, or maybe there's some open source connector that allows you to ingest this. I know Delta and Iceberg becoming kind of like a very popular format. This is kind of like this Delta you're asking, right? Or you're asking Delta? Yeah. I think support this in a data manager in StarTree Cloud. Might not be available in open source, or maybe it's available through third party. I don't believe it supports out of box. I need to check. But this is a very good question. I remember someone asked me, but I don't use this often. I think which is Google. Naming is hard, as always. The input formats. So open source supports CSV, Avro, JSON, Thrift, Parquet, Orc, and Protobuf. I'm pretty sure that StarTree Cloud's Delta Lake connector. Yes, it's a StarTree Cloud. So it's not available in open source. It's it's a cloud thing, but it does support the Delta as a ingest inside the cloud. All right, cool. Class dismissed. Thank you so much for your time. I hope we'll see you online or maybe on the future meetups. It was great. Thanks so much for coming, because today was rainy, 4 presidents in town, and the holiday is coming. That's some dedication. I appreciate this. Thank you so much for sticking around.